Welcome to the Computer Chronicles. I'm Stuart Chaffee, and this is Gary Kildall. And Gary, this is a product called Ractor. Ractor claims to be able to have an intelligent conversation with you. I just asked it if it uses artificial intelligence, and it's so dumb it can't even figure out what I'm asking it, actually. The makers of Ractor claim it has AI, but they say that's artificial insanity, which may or may not have anything to do with artificial intelligence. Gary, seriously, on AI, this is one of those areas in which there have been so many promises, but apparently not that much delivery. Are there really any artificial intelligence products out there today?
Well, Stuart, the real beauty of artificial intelligence is that it's a moving target. Once the basic research results in a product, it's no longer interesting artificial intelligence work. 20 years ago, Samuels had a checker playing program that was considered good basic AI research. Today, it wouldn't even make it into a Macy's store. So we hear about products nowadays that really have things like, well, they claim things like natural language processing, expert system capability, things of that sort. We have to now figure out what's the fluff and dazzle and what's the substance.
Well, we're going to try to find out today by taking a serious look at artificial intelligence. We'll meet some of the top names in the country in the AI field, and we'll see some fascinating demonstrations of artificial intelligence at work. We're going to begin by taking a look at a vision recognition system that uses AI to interpret what it sees.
Human beings are equipped with stereoscopic vision, a distinctive feature that allows us to judge distance and the relative placement of objects. In addition, humans know how to identify the features of a landscape by color, shape, or placement. But how can a computer be programmed to do the same with the same limited information? In Palo Alto, California, a machine vision project is underway to automatically produce digital terrain models by scanning stereoscopic photographs of the Earth's surface. Working from illumination densities and reflectance values, the terrain modeling system, with some human assistance, can calculate an image from any point of view. It can then synthesize a flight path through the terrain based on any chosen route. While the process of creating topographic maps is simple geometry for a human being, scanning a photograph, no matter how detailed, is full of ambiguities. Tall objects obscure smaller ones. Repetitive patterns can be confusing, and forms can be misinterpreted. To overcome these ambiguities, the SRI project is experimenting with artificial intelligence. The goal is to develop a program that can look at the global constraints of an image, the parts in context with the whole. Like much of today's government-funded AI research, this program is slanted toward military applications. But its future potential will help us recreate more exotic views, from the inside of a human body to the outside of the moon.
Joining us now in the studio are Dr. Harry Tennant, senior member of the technical staff at Texas Instruments in Austin, Texas, and Dr. S. Gerald Kaplan, principal technologist for Lotus Development Corporation of Cambridge, Massachusetts. Gary?
Jerry, the first question. AI is one of those things that people are appending to their products now to make them fancier, add the frosting, and make them sell better. It has a chance of, I guess, in a sense, being misused. And how do you characterize AI in this new technology you're working with?
Well, really, artificial intelligence is a fundamental software technology that's of interest primarily to people developing software. It's not an end-user product in and of itself that one would want to sell or to... there really isn't much of an AI market except for the tools market, and we're going to see some of the tools here today.
Well, characterize some of these things. What are the kinds of things that you'd say AI can add to?
Well, what it
products?
can add, well, first you have to understand what it is. It's really methods for programming using symbols and describing their interrelationships, and then being able to reason about them to reach some kind of conclusions or enhance some existing type of application. What we're going to see in the next few years is a continued growth in the utility and intelligence, if I can use the word loosely.
Making the programs a little bit easier to use and a little more intelligent.
A little more intelligent. We're going to begin to see out of Lotus, certainly, and other companies, programs that begin to know more about their intended use, and that can help the user by interpreting the user's intentions as opposed to executing the user's commands.
Okay, Harry, that's a perfect introduction to what you've got
Give
here.
us an example of it.
You've got a natural language system, one part of AI first, and show us what that is.
That's right. What we have is a way to ask questions of the computer in English so that the user doesn't have to learn an arcane computer language before he gets started. In this case, what I'm going to be doing is building a sentence up in this portion of the screen out of words and phrases that I select from the menus down below. For example, the sentence starts with show, show the average number of days of sun, in, and now I'll choose a city, in El Paso. Now I've got a complete sentence, and I can ask for the answer. Show the average number of days of sun in El Paso, 319 days. Now, the benefit of this is that somebody who doesn't know anything about the kind of database that we're interfacing to or anything about how to command that database can come up and immediately see what kind of information is in there and can immediately find out how to get the information out.
Harry, can you actually do the inverse of this process and type the sentence in immediately, or is it something you select off the menu and construct a sentence?
You select off the menu and construct the sentence. I had been doing research in the area of natural language processing, which is the act of typing in the sentences and so on, for quite a few years before I came up with this approach. The benefit of this approach is that 100% of the queries that the user puts in will be understood because the user finds out what kind of sentences he can put together, what kind of things the system is going to understand.
How would you compare this with products that say where you actually type sentences in and there's algorithms and heuristics that actually go in there and try and figure out what the sentence is? Is this the same kind of a product, or is this a different kind of thing?
Yeah, what we did was, if you take away the menus, behind the menus lies the exact same technology that's in the conventional natural language systems. All we've done, there are limitations to any natural language understanding system, and all we've done is to reveal to the user what the extent of that system is and what the limitations are.
So if one were to peel this layer off, you could actually start typing sentences and it would understand that, so the underlying algorithms are like that then?
That's right.
Okay.
Okay, Harry, you have now an expert system you're going to show us, and I know
Yes.
you've got to reload there. If you could do that for a second.
All right.
And Jerry, I'd like to ask you now, we're trying to get a handle on this definitional problem. Now, what we just saw, would you call that artificial intelligence?
I would say that that's really in the category of a tool, and what you've seen is an application of that tool to querying a database in particular. That's all I would say.
So who knows?
I really don't think it's accurate to say one thing is or is not an AI product. AI is not something special that you add to an existing program. It's an approach to programming and creating programs that are flexible or useful or solve problems which previously might have required some kind of human intelligence or attention.
Well, it's certainly the case that there is a gray area there between what we could call a user interface and something that really understands the sentence.
Yes.
And that's,
I think I would define AI a little bit differently from what we've heard. AI, when it started out in the early 50s, was really a set of problems. How can we make computers reason? How can we enable them so we can talk to them or let them see? Or other problems like that that we recognize in humans that we do, and we associate that with intelligence. How can we take that same capability and put it into our artifacts, into our computers? Well, it's this range of problems that make up what is AI. We've developed a whole collection of technologies to address those problems. The natural language that I've demonstrated is one of the approaches. There are many, but one of the approaches to that sort of problem.
Okay, show us the expert system
is another. Now, what we have here is a technique for decision-making and making of judgments, in this particular case, for diagnosing problems with your car. The system is asking, what is the problem? Well, my car is making a strange noise, so I select that choice. Does the noise change between standing still and driving? Yes, it does. Does the noise change on a different type of road? Well, no, in this particular case, the road doesn't make any difference. Is the noise a squeal? Yes, it's a squeal. Is the noise most obvious when starting the car? No, for my problem, that's not the case. Is the noise most obvious when braking to a stop? Yes, it is. Well, the system has come to a diagnosis of the problem. And the diagnosis is that the brakes may be glazed, the rotors or pads of disc brakes, or the linings of drum brakes should be inspected for glazing or dirt.
Okay. Now here, in this particular case, this is again for clarification, how does this differ from, say, just a strict yes or no decision-making process, getting you down to the point where that someone has literally put in all the yes or no answers, get to the final point? Are there judgments and valuations put on each one of these
Now, the real difference that comes through expert systems as opposed to other programming techniques is what Jerry was talking about earlier, is the way that the system is programmed. In this particular case, the case of building rule-based expert systems, as they're called, the The knowledge that goes into it is in the form of a collection of rules, the little pieces of information that chained together can build up to make decisions.
And these rules come from where?
They come from an expert, somebody who knows how to fix cars.
Now, behind this, is there a generalized tool that, say, can be applied to not only automobiles, but, say, fixing refrigerators?
Absolutely. What's behind this is a tool that can take these rules, these little pieces of information, for whatever context you're in, and tie them together to make a decision or make a judgment.
Now, is this general knowledge going to be applied to virtually anything? Any kind of a
well, virtually anything is a big field.
If you had an expert that would come and write rules about, literally anything an expert write rules about, could this system apply to that?
The fact is that expert systems are being applied to a very broad range of applications. For example, there was one developed at Johns Hopkins for diagnosing poisoning situations that you can have on a hotline. When somebody calls in, you find out what to do about.
We've seen that here. In fact, Jerry, we have just about a minute left. You mentioned that at Lotus you are working on some ways to use AI, whatever it is, in application software. Give us a clue as to what areas we can see coming up.
Well, I think what we're going to see is improvements really in 3 ways. The first is new classes of applications and products, and of course I'm not about to pre-announce anything, so I have to be somewhat circumspect about talking about that. But we're looking into areas of flexible databases, just certain kinds of decision support systems, programs that will help you to keep organized, help you to carry through rational processes that typically are easier for machines than for people.